For 50 years, theoretical physics has resided in a state of high-precision gridlock. Our most successful models describe the universe with staggering accuracy, yet they remain structurally incompatible with one another. String theory successfully identified particles as one-dimensional objects under tension, but the math required 10 dimensions to function, leading into a landscape of 10 to the 500th power possible and largely untestable universes. Loop quantum gravity produced a discrete background and incidence time, but it stalled when it couldn't derive its own fundamental constants. Researchers had to manually import those values. Quantum field theory achieves precision out to 12 decimal places, but its calculations naturally explode into impossible infinities. Physicists rely on renormalization, a mathematical subtraction trick to remove those infinities. To calculate the strong nuclear force, Lattice QCD physicists divide spacetime into a discrete grid. For 40 years, they've used a specific numerical formula to make their supercomputer simulations match reality without knowing its geometric origin. These theories act as fragmented, incomplete maps of a single, invisible terrain. Every standard model shares the same crippling assumption that the universe is a pre-existing empty container where objects are placed and events occur. Geometric boundary projection replaces the container with a single postulate. Time is a one-dimensional string under tension, propagating at the speed of light. This tension physically defines the constant c. The speed of light is not a speed limit for objects moving through space. It is a mechanical property of the time string itself. Time functions as a physical property carried by every individual object. Instead of moving through a universal stage, you traverse the length of your own time string. Space emerges whenever an interaction pushes against the tension time string, causing it to deflect. Under transverse pressure, a tension string naturally bends into a mathematically precise parabola. Because this deflection has an interior volume, locating any point within it requires 3 distinct coordinates: a radial distance, an angle, and a position along the string's length. These 3 interior axes serve as the x, y, and z of our experienced spatial dimensions. Quantum fields represent the continuous tension of this shared 1D substrate. Every particle in existence remains physically connected to every other particle through the string itself. Entangled particles communicate instantly because they share a direct topological shortcut through the time string, effectively bypassing the 3-dimensional space sitting between them. This topological extension explains the Aronovo-Bohm effect, where an electron is influenced by magnetic potentials it never touches. The electron reacts because its own local geometry is physically extended into the field's region. All spatial phenomena and distances are localized geometric consequences of time string deflections. To achieve stability, the parabolic wave of a particle must return to its starting point and close into a continuous loop. Closing this wave creates a resonance problem. As the wave circles back on itself, the outgoing and returning phases overlap, causing most possible paths to vanish through destructive interference. The geometry enforces a strict consistency limit. To account for 3 color charges, 2 spin states, and the 5-fold structure of the electroweak force, the loop must adhere to a 30-step lattice. The interference destroys every path except for those coprime to 30, leaving exactly 8 distinct, stable winding lanes. These 8 surviving geometric lanes provide the physical origin of the 8 gluons observed in the strong nuclear force. This framework defines particle mass as the projection cost of a specific winding path. A particle's mass is simply the energy required to maintain its winding geometry against the time string's tension. This geometric mass formula is algebraically identical to the Lucier-Weitz correction that Lattice QCD has used blindly for 40 years, suggesting the terrain was hidden in the supercomputers all along. Gravity functions differently than a traditional force. It does not require a carrier boson traveling through a vacuum. Gravity is the localized relaxation of the time string's tension. As winding energy accumulates, the local substrate sags and loses tension. Black holes represent the boundary where this local tension reaches its absolute mathematical floor, creating a physical limit where the geometry of the time string can no longer be sustained. This realignment validates string theory's core insight of tension strings, but places the extra dimensions inside each particle's internal winding, rather than in a global universe. It reconciles loop quantum gravity by showing how its discrete spacetime structure and its missing parameters are derived from the mod 30 geometry. The mathematical infinities of quantum field theory served as geometric limit markers, signaling that the equations had finally exceeded the particle's physical boundaries. The maps of the standard model are correct, but the universe beneath them is simpler. One tension string, mathematically forced by its own geometry to construct reality.